Okay, hey guys. Today you have your test over systems, but before we get started, we're going to go ahead and go over the warm-up together. By now, you should have turned in your test review because that's going to be a grade, so if you didn't, now is your very last chance. Know that as soon as you finish your test, which I want you to have about an hour to do, you will pick up your EOC review homework. It's kind of long, but it's very important that you do because it starts to go over EOC questions because we're officially in second semester and the EOC is well on its way. So take that seriously, work on it after your test, and then you can come in for tutorials if you have any questions on that. So that's your homework over the weekend and due next class. So let's go ahead and look at number 1 on our warm-up. I'm going to try to go over this quickly so you can have time to test. Number 1 says that 2 furniture salesmen are comparing their salaries. Tom is paid $200 a week and a 15% commission on his total sales. Bob is paid $360 a week and a 10% commission on his total sales. If they have the same amount in their paycheck, what were their weekly sales? So with commission problems, we're always talking about 2 variables. Let's say Y is our money and X is the number of sales. Okay, so our money depends on our sales. Now, we can say that Tom makes $200 just for showing up plus a 15% commission per sale. So we turn that 15 into a decimal, 15 over 100, and we put an X next to it. Bob gets $360 just for showing up to work plus a 10%, 10 over 100 is 0.10 X per sale. Now, the question says that they have the same amount. So I know that the money from Tom gets should be equal to the money that Bob gets. So these two should be equal to each other. So I'm going to take Tom's money and set it equal to Bob's money, because that would represent when they have the same amount in their paycheck. So now I'm just going to solve for X because I want to know what are their weekly sales. Well, which variable is sales? X. So I've got an X on 2 sides. I'm going to move it to one side. So if I go ahead and move this 200 over, that will give me 0.15x equals 160 plus 0.10x. And then I'm going to minus 0.10x on both sides. And that will leave me with 0.05x equals 160. Then I just divide and I get that X is equal to $3,200. So I know that if they have $3,200 in sales, that they will make the same amount on their paycheck. Okay, so with commission, remember Y is money, X is sales. Let's do some fill in the blank. Number 2 says 2 lines that are blank have no solutions. So what types of lines have no solutions? Parallel. What kind of slopes do parallel lines have? Think of your little song. Parallel lines have the same slope. So if you find a slope and you can tell that they're the same, but different y-intercepts, you'll know that they're parallel lines, they have no solutions. The next part says when solving by substitution, or elimination for that matter, how do you know that they have no solution? Well, that would happen when your variables eliminate and you get left with something like 0 equals 7, which is not true. So if your variables cancel out and you get something that's false, then you'll know that it's no solution. So that's one way you can do it. You can either solve for y, compare the slopes, or you can just solve it by substitution or elimination and get something that's false. The next one says 2 lines that are blank have one solution. One solution happens when you just got 2 lines that intersect. Okay, so they're going to cross, intersecting. They're going to cross at one point. That's their one solution. So that means that their slopes, if they have different slopes, you know that they will cross one time. So if you solve them for y, they're just going to be 2 different lines, different slope. If you're solving by substitution or elimination, you can find the solution. And there's only going to be one. Last one, 2 lines that are blank have infinite solutions. Well, that's if they're the same exact line. They share every single point. So it says, when solving by substitution or elimination, how do you know that you have infinite solutions? Well, your variables eliminate, and you get something like, not x, sorry, 0 equals 0, something that's true. They're the same line. If you're looking at the slopes, they should be the same, and if you're looking at the y-intercepts, they should be the same, or you get a true statement if you use another two methods. Okay? So parallel, no solution; intersecting, one solution; same line, infinite solutions. Those are our three cases. Number 5, a certain number is 2 more than 4 times another number. Their sum is 182. What are the two distinct numbers? Okay, so let's say that a certain number, let's call that y. So a certain number is, if I write that in math terms, it's going to be y equals 2 more than 4 times another number, which I'm going to call x. So 2 more than means I'm adding 4 times another number, 4x. That takes care of the first sentence. Now I'm done with that. Their sum is 182. So that means that a certain number, or I'm sorry, another number plus a certain number equals 182. If I want to solve this, the best way would be substitution. I'm going to substitute this in for y. So that means I'm going to copy down my second one. Instead of writing a y, I'm going to write 2 plus 4x equals 182. Combine like terms. 5x plus 2 equals 182. Subtract over the 2. 5x equals 180, which tells me that x equals 36. Okay, so one of my numbers is 36. If I want to find the other number, I'm going to plug this back in here. Y equals 2 plus 4 times 36. 2 plus 4 times 36 is 146. Okay, so my answer, 36 and 146. It's a nice